Alright, let's look at the remainder and factor theorems and how that will be related to what we've been studying. So, you're going to evaluate functions using synthetic substitution, and you're going to determine whether the binomial is a factor of a polynomial. And you're going to see how you can use the idea of synthetic division to factor, which is actually kind of interesting. We're starting to get into some higher level math stuff here. Or at least what I think is higher level math stuff. Anyways, let's look at the next thing. Let's talk about synthetic substitution first. The best way to describe synthetic substitution is, you know how you do those functions where you plug in a number and you put it into the x and then you give me an answer? Well, you can use synthetic subdivision to kind of do that same thing. For example, if we have a function that states what this one's going to state, 3x to the fourth minus 2x cubed plus 5x plus 2, find f of 4. Well, okay, yes, I know, you could plug the 4 in place of the x and find the answer. But you could also do this. You could actually say, set it up like a synthetic division. Notice, 1, I'm putting a 0 because I'm skipping the x squared, and 2, I did not change the sign of whatever's in there under the parentheses. It will go back into that synthetic substitution like that. Plus 2. Why did I put a plus 2 if I have a... Boy. Okay, anyways, I put a plus 2. Don't worry about it. You didn't have to put a plus 2, but I put a plus 2. I'm just going to erase that plus 2 because it's going to annoy me. Alright, anyways. So, because again, there was nothing in between x cubed and x, and there should have been an x squared. Oops, now I forgot I have the eraser still on. There should have been an x squared. Then I had to put a 0. So that, remember, it's x to the fourth, x cubed, negative 2 is the x cubed, 0 is the x squared, 5 is the x, and 2 is the number by itself. So we start off like we normally do. Bring down to 3. 3 times 4 is 12. 12 minus 2 is 10. 10 times 4 is 40. 40 plus 0 is 40. 40 times 4 is 160. 160 plus 5 is 165. 165 times 4 is 660. Plus 2 is 662. So what does that mean? Because that means nothing to me. Look, all you care about is the remainder. If I ask you to evaluate using synthetic substitution, you are telling me f of 4, if I were to put the 4 in place of those x's, my answer would be 662. So f of 4 is equal to 662. Yay! Let's look at another one. If f of x was, let's find out, 4x to the fifth plus 2x cubed plus x squared minus 1. Find f of negative 1. Okay, again, negative 1. Oh, I skipped the 4 and this. Stop it. I had skipped the 4 and the x. So notice that since it was x to the fifth, I had to have 0 for x to the fourth. This is very important that you do not miss the zeros. I noticed on the last test, some of y'all were skipping, like if it missed in 2 spots, you only gave me 1 0. You got to give me both. So you got to pay attention and make sure you're noticing what is what. Alright, so I'm just multiplying by negative 1, adding, multiplying, adding, multiplying, combining, and I've got that it was negative 6, so f of negative 1 is equal to negative 6. If I were to put negative 1 in place of the x, I would get an answer of negative 6. And there we go. So this is not really all that difficult when you think about it. Okay, so now let's get into the factor theorem. This is the more interesting part of this lesson. A binomial factor, the factor theorem states that binomial is a factor if there is a remainder of 0. Okay, so basically, think of it like this. When you divide, if it comes out even, you know that number is a factor. For example, if I divide 30 by 5, I get the answer 6. There is no remainder. So I know that 5 times 6 equals 30. So that means that 5 is a factor of 30. Okay, factors are those numbers that can multiply to get you that thing or divide evenly. Okay, so using that idea, let's go too far. Is x negative 5 a factor of x cubed minus 7x squared plus 7x plus 1? Well, the neat part about this is if I want to, I can do synthetic division, and you can see me going through the synthetic division here. If I get a remainder of 0, I know x minus 5 is a factor. So that means x minus 5 times whatever would have given me this polynomial. Okay? Now, if you look at this, again, look at the answer. The answer, if that was x cubed, that means this answer is x squared minus 2x minus 3. Well, go back. So that means that x minus 5 times the x squared minus 2x minus 3 would multiply to give you x cubed minus 7x plus minus 7x squared plus 7x plus 15. Now, in theory, if you can factor that further, you can fully factor this out. And that's when we start getting into this more intriguing idea. How can we fully factor? So, I'm going to let it play through here, and you can kind of see how it fully factors out x minus 5. And then I can say, okay, I've got x squared minus 2x minus 3. That's quadratic. So I can go x minus, x plus, and then see what it factors out to. Sometimes maybe you can't factor. Maybe it is done, but that's it. But in this case, I do have two numbers that multiply to give me 3 and subtract to give me 2, as in 3 and 1. So then, there it is, fully factored out. So x minus 5 times an x minus 3 times an x plus 1 would multiply to give you that x cubed minus 7x squared plus 7x plus 15. Ugh, that's a lot. So, there you go. So here's one more example. Is x minus 1 a factor of x cubed minus 6x squared plus 11x minus 6? Well, let's find out. Alright, so I'm going to go through the steps. You know, the multiply and combine. Yes, it is. So that means x minus 1 was a factor. And then keep in mind that this is an answer, and that's also another polynomial. That one is x squared minus 5x plus 6. And then I could say, oh, well, let me see if I can factor that further. X, and yes, you can, of course, because I set it up that way. Minus plus is minus minus. 2 times 3 is 6. 2 times 2 plus 3 is 5, and there you go. So you can kind of see here, and see, what this is allowing us to do is that eventually we're going to upgrade this to where we can come up with numbers that could possibly work and literally start creating the factors and just use synthetic division to help us find factors. And I'm going to show you how later on how you can use a calculator to even help you kind of start figuring out what some of those numbers may be and go from there and try to make things a little bit easier. But there you go. That is the remainder theorem and the factor theorem. That's all for today. Thank you very much. Take care.